let's keep to the basics of sound. What is given in the chapter? In the later chapter, you'll get to understand what waves are in general. When it comes to sound, I prefer my students to memorize the definitions as well to understand it in a better way. Sound gives you sensation of hearing. Because of sound, you are able to hear things around you. Okay? To listen or hear objects around. Second important point is how sound is produced. First, medium dependent and vibrating body. So, if there is a vibrating body, uh, and medium present, we could produce sound. Okay? This means that sound requires medium for its existence and sound requires a vibrating body. So whenever we are talking, whenever we're speaking, our vocal cord provides the necessary vibrations. These vibrations are shifted to the air in front of it, and that air, when reaches to your eardrum, it vibrates according to the vibrations of sound that we have produced, that I have produced. Okay, that eardrum vibrates according to the sensation of sound of vibrations that my sound has produced, and you're able to hear things around you. So sound is is a type of wave which produces sensation of feel. ठीक हो गया? And how sound type of wave sound is which type which type of wave sound is. Let me explain to you what is the meaning of wave first. Okay? Wave is a phenomenon which transfers energy without transporting medium. Okay. Wave is a phenomena which transfers energy without transporting medium. That is when I'm talking to you, you're able to hear my sound, which is a form of energy reaching to your ears. There is no kind of matter transferring alongside with it. So wave is a phenomena which transfers energy without transporting medium. Matter transfer nahi karta. We could also write matter without transporting matter. ठीक हो गया? Now let's get back to the point which we were about to discuss. Which type of wave sound is? So sound is longitudinal in nature, which means sound travel in straight line and sound is longitudinal in nature, which means sound travels in straight line. And what longitudinal means? Let's get to that. Longitudinal means a type of wave in which particle motion and propagation of wave or traveling of wave wave is parallel to each other. Now, as I discussed in the beginning, that sound needs a medium and a vibrating body, which means there would be some particles present when the sound would travel. So, in order to explain that, when the particles of sound travel across the medium, the particle of that medium moves back and forth, and energy transfer took place like this. Okay? So particle is moving back and forth, and wave is also traveling in the same direction. Travel of wave. So they both are parallel to each other. This kind of wave means longitudinal wave. So sound is longitudinal in nature. So far we have discussed what sound is, how sound is produced, which type of wave sound is. I hope you understand this part. Let me know if you have any questions with this. आप उसको So to show that how sound travel across the medium, we can take help of this example, or there would be a spring example alongside with it. Let me take you there as well. When you pull the string back and forth like this, okay. A string is being pulled back and forth like this. So a particle उसकी वजह से कैसे move करेगा? It would move like this, and it is traveling in this direction. So these both are parallel to each other. These types of waves are known as longitudinal wave. This is tuning fork. This black thing is tuning fork. When we hit it with some surface, it produces a vibration of certain frequencies, which is written on it. Na? So when we touch this with the glass of water, it would splash out, which means visibly we cannot see the tongs moving. But when we'll touch it with the water surface, the water would splash, showing us that some kind of vibration is moving. So whenever sound is traveled across the medium, you could see with the diagram, it would move the particles in front of it back and forth. And the energy would carry out through the medium exactly like this. So the wave is traveling in this direction and the particle is moving back and forth like this. So these both are parallel to each other. These compressed part of the waves are known as compression. These stretched part of the waves are known as rarefaction. So the sound travel in the form of compression and rarefaction. Compression are the compressed or high density area of the wave, and rarefaction are the low density or low energy part of the wave. So the sound would travel in the form of compression and rarefaction across the medium. And each this bar you could see here, this line, this is known as wavefront. Wavefront is defined as the mode in which the waves travel across the medium. किसी न किसी फॉर्म में तो ट्रेवल करेगी. So जिस फॉर्म में वो ट्रेवल करती है across the medium, that is known as wavefront. So I could write here sound travel in the form of compression and rarefaction. Sound travel in the form of ये longitudinal waves basically are comprised of compression and rarefaction. So these things are not any different. It's just the name that we give to each and every part of the wave. ठीक है? Compression and rarefaction. मैं यहाँ पे for your information I write it down that longitudinal waves are made up of compression and rarefaction. I have shown you the diagram of what compression and rarefactions are. So to write it down for you, I'll just write here that compression are the compressed part of the wave. Compressed भी कह सकते हैं, we can say high density, high energy part of the wave. Obviously, where the particles will be closer together, like when the particles are very close together, so here energy level would be greater. Okay? Would be greater. So does the density. So compressions, these are compressions, compressed part of the wave, and rarefactions are the part of the waves which are further away from each other. Okay? Energy level is 2. And why is that? Because the particles are further away. Further away in a way कि उनकी energy low होती है, we wouldn't say it would be further away because in the same kind of a medium there would be no difference like that. But the particles are low in energy. That's enough. The particles are low energy. Let's not write that they are further away. It's not something that we have different state in one medium. So these are rarefactions. Stretched part of the wave. Compressed part of wave. Also, this one line this is wavefront, or we define wavefronts as an imaginary line on which each particle is moving with same phase of vibration. That is, we have these particles set on an imaginary line. Let me use a darker color. These particles are set on some imaginary line. Same phase of vibration means they all would go up together and they all will come down together. Such an imaginary line is known as wavefront. Am I clear up till now? Or if there is any confusion, just go ahead and ask the question.
I don't understand wavefront.
Wavefront is something how waves travel across the medium. Okay? It's how you could say it's how wave is traveling across the medium. It is independent of longitudinal or transverse. It's just how wave travel. Wave travel across the medium in the form of circular wavefronts. Have you seen the waves produced in the water surface whenever you throw a stone inside the water? You see that the circular rings is produced whenever you
Okay.
throw a stone in the water. Those circular rings are known as wavefronts. That's how wave is traveling across the medium. And you see that na, we have concentric circles, which means on a particular circle, nothing is moving out of it. It's a clear circle. That means on this particular circle, all the particles would be moving in the same state of vibration. They all will be going up and they all will be going down together. So wavefront could define if the definition is asked, it's an imaginary surface. Through water we could see, otherwise we cannot see the wavefronts. But if we can see it, wavefront is something how wave is traveling across the medium. In terms of definition, it's an imaginary line on which each particle is moving with the same phase of vibration. Okay? That all the particles are going up together and all the particles are going together down. whenever it comes to waves, we should understand the meaning of the medium, how important the medium is across it. Because when we're going to further discuss sound, now, we will see, Acha, if I ask you, sound would travel faster in solid, liquid, or gas, in which it would move fastest?
Gas?
In which state the sound would move fastest? Solid, liquid, or gas?
Solid या gas?
किसमें सबसे fastest हो?
Solid?
And why is that?
Because उसकी
What comes to
density
your
high
mind the
होती है.
first? Yes,
Because
the
density
density is
high
high,
होती
the
है.
particles are, yes, the density is high, the particles are very close to each other. That is why sound travels fastest in solids than liquid than gases. So moving on to the next part. So far we have discussed about what sound is, how sound travels, what compressions, rarefactions are, what wavefronts are, alongside with the definitions of each and everything. We have also discussed that the sound travel fastest in solid, then in liquid, and then in gas. And the reason behind that is solid is most dense, then liquid, then gas. Because particles are very close to each other, so the energy transfer would be faster as particles are closer, so energy would be transferred faster. Also, if we are discussing about the density, we also can discuss on the state, depends on the state of matter. Would the temperature affect the speed of sound?
No.
Temperature would have no effect on the speed of sound. Direct
It
relationship,
will
right?
have. It will.
Yes,
Because
because
the जब आप
as
high or out.
yes.
बोलिए.
नहीं, you're telling right. I'm just waiting for the
कि जब
answer.
आप हाई ऑल्टीट्यूड पे जाते हैं तो आपको इतना नहीं सुनाई देता क्लियरली.
Mhm. That has to do with the pressure and density. Temperature has a direct relation with speeds of sound because as temperature increases, so does the speed of, sorry, so does the kinetic energy of the particle. And it would exchange its energy faster. Because once the kinetic energy of the particle is greater, it would collide more fastly, the collision rate would increase, and as the collision rate would increase, thus exchange of energy would be faster. Am I clear about this point? So, as the greatest speed would be in solid, and then liquid, and then thus gas, that is normally in air, the speed is 320 meters per second to 340 meters per second. But if you would increase the temperature of the air, the speed would increase automatically because the kinetic energy of the particle has increased. You do not need to memorize these values. You just need you must know the comparison of the speeds across the mediums in terms of state of matter, in terms of temperature. Clear? And there are two terms attached with the sound that is known as pitch of sound and loudness of sound. Pitch depends on the frequency. And it tells us how shrill or grave sound is. Loudness depends on amplitude. And it tells us how loud or shallow sound is. ठीक हो गया? So if I have a wave like this and someone say the pitch has increased, this would mean now there would be more waves in the same period of time. ठीक है? Why is it cleaning up? Frequency होता है. Frequency is defined as number of waves per second. And amplitude is defined as the maximum displacement of particle. If I draw a particle, if I draw a wave, this is one wave. This is known as crust. This is known as trough. The frequency would be 1 because there is only one wave. And the unit of frequency is hertz. If I draw another wave, now the frequency would be 2 hertz. If I draw another wave, the frequency would be 3 hertz. If I only draw a half wave, what would the frequency now? 3.5 hertz. So if the frequency, if the examiner says the frequency has increased, this means the pitch has increased. So if the pitch has increased, now we would have more waves in the same period of time. Now count on how much waves do we have? Let's count. यहाँ तक 1, 2, 3, 4 and 4.5. The pitch has increased. ठीक है? The number of waves in the same period of time has increased. So that's what pitch means. And loudness is this amplitude. Let me raise this part. This amplitude, this maximum displacement, this is known as amplitude. Higher the amplitude, louder the sound would be. Lower the amplitude, lesser the sound. Clear? Let me take you to the part where you would understand in terms of waves. I guess the pitch and the amplitude part is not the part of the syllabus anymore. No, it is because there is a question. So, which would have a greater pitch out of 1, 2, and 3? Frequency किसमें ज़्यादा है? Out of 1, 2, and 3.
3 में.
ठीक है? And frequency same किसमें है?
Same भी 3 में ही है.
Frequency same किसमें है? 1 and 2 में. ठीक हो गया?
1 and 2 में कैसे है?
देखो नंबर ऑफ वेव्स इक्वल है ना 1 एंड ये यहाँ पे भी उतनी ही वेव है. ठीक है? सो इन दोनों की फ्रीक्वेंसी सेम है बट एम्पलीट्यूड किसका ज्यादा है आउट ऑफ 1 and 2?
2.
which has a greater amplitude out of 1 and 2? So we could write as, yes. Let me copy this diagram and put it in the notes section so that you could have it whenever you need it. So let's start writing. 1 and 2 have same pitch, but 2 is louder than 1. Wave
ए आएगा
and whereas 2 and 3 में क्या common है? 2 and 3 में क्या common है?
वैसे 3 ज्यादा
Whereas
लाउड
whereas 2 and 3 have same loudness. How do we know we have same loudness? We could see here that 2 boxes up and 2 boxes down. Similarly, 2 boxes up and 2 boxes down. We never take this whole section as an amplitude. That's wrong. Amplitude is equilibrium line say above or below the equilibrium line. Okay? So 2 and 3 have same loudness, but 3 have bigger pitch than 2. ठीक हो गया? That's what loudness and pitches and the terms that we have studied so far. Let me know if you have any question. Okay. Continue with the sound topic. We're left with only 2 more topics. That is how to calculate the speed of sound. Second is formula for speed of sound. Third is what is echo. Okay. Rest we have almost completed. And there is this one thing left, how we can visualize the sound, right? Starting with how we can calculate the speed of sound. For that, we need to memorize an experiment, or memorize or just understand an experiment, that how we can find out the speed of sound using certain things. Let me show you that. When it comes to speed of sound, we take help of this experiment. Let me put it out in my notes. We continue. When it comes to speed of sound, obviously, हम लोगों ने in the previous chapters we have studied that the speed, the formula of speed is given as speed is equals to distance over time. That is, if we want to find out the speed of sound, we need to find out the distance from where the sound is coming and how much longer is it taking for sound to reach to us. For that, we take help of this experiment. We take 2 microphones attached to the same timer, placed at an appropriate distance, that is 1 meter or 1 meter, 2 meters, so whatever. The larger the distance between the 2 microphones, the greater accuracy we're going to have. Okay? Then we'll produce some kind of a sound, that is a clap or something, in front of the first microphone, that would turn on the timer. When the timer is turned on and the sound reaches to the second microphone, the timer would be switched off. Now we have time from the timer. We have distance between the 2 microscope. We'll put it in this formula and we'll get the speed of sound. You need to keep this experiment in your mind whenever the examiner asks you to discuss an experiment through which you can find the speed of sound. Okay? If we put it into theory, first point क्या आएगा हमारे पास? Take two microphones and place it at an appropriate distance. Must write this point. The larger the distance, greater will be accuracy. तो ये भी लिख सकते हैं attach it to electronic timer and place it at an appropriate distance from each other. Second, produce sound in front of microphone 1. This would turn on the timer. Third, as soon as the sound reaches the microphone 2, let's write this is M1 and this is M2. The timer will be switched off. So T हमें यहाँ से मिल जाएगा, T हमें यहाँ से मिल जाएगा. Put this in the formula to find out the speed of sound. We already have discussed that speed of sound depends on two factors, the state of matter and the temperature. So it is greatest in solid, then liquid, then gas. And when it comes to temperature, the greater the temperature, the faster the speed of sound will be. There are other parameters as well, pressure and density. Density somehow covers with the state of matter, but we do not discuss pressure in this course. But in the later on, you will study about how the pressure would impact the speed of sound. Normally, let's not get into that. Let's stick to this point. So we have these two parameters covered, that how to calculate the speed of sound and what is the formula of speed of sound. Then we are left with the last term, which is echo. What is the mean of echo? Echo is the reflection of sound. Echo is defined as the reflection of sound. In order to find out the echo, the formula that we use is 2D over T. Because if there is a surface in front of it, so the distance traveled by the sound, and after reflecting it from there, it will cover a distance of 2D, and the time taken by it will put in the formula to calculate the speed of sound. So echo is basically the reflection of sound. Then there comes a question how we can visualize the sound. To visualize the sound, visualize means to see the sound, how we can see the sound. To visualize the sound, we use oscilloscope. Oscilloscope is a device which shows electrical signal in waveform. So microphone converts sound into electrical signal, which is given to oscilloscope as a signal, input signal. Oscilloscopes look something like this. I showed you that yesterday, but this is how oscilloscopes looks like. So this is the source of sound. Source of sound. This sound is in analog form. Let me use some other color, which is brighter. Black would be fine, I guess. Analog form. Analog means continuous signal. Okay. This is a source of sound, which is in analog form, and analog means a continuous signal. This is the microphone. As explained, this would convert sound into electrical signal. And you could see this is placed as an input here, and this is how sound look like of a इसको क्या कहते हैं? I forget out, skipped out of my mind. Whatever it is, I forgot the name of the musical device. Anyhow, do you get how? Do you understand the point? How can we see the sound?
हाँ जी.
Now the last part that I already explained it to you. Let me just show in the form of the diagram. That is on a waveform. How do we read the sound? So this is a time period. Time period could be from here to here as well. Any point. We start from a certain point and end exactly on a certain point. So from here to here, we have one wave. Distance between the wave. So in order to, what wavelength is the distance between, they have not mentioned the wavelength here, but we can find out the wavelength as well. Wavelength is defined as the distance between two consecutive crust or crust. If we consider this as an equilibrium line is defined as the if we discuss this as an equilibrium line, yeah. Equilibrium line, it is defined as a line on which each particle is at rest. ठीक हो गया? So this part of the wave is known as crust, and this part of the wave is known as trough. So distance from any point, let me draw another wave. If this is the wave, okay. If I'm starting from here and ends here, this is one wavelength. If I'm starting from here to here, this is one wavelength. If I'm starting on this point, then exactly on the second wave, this point is one wavelength. This is between any two points on a wave is known as wavelength. Time period is defined as the time required to complete one. This is time period. which is defined as time required to complete one oscillation. Spelling are totally messed up. To complete one oscillation. And again, I repeat, it could start from any point and end exactly on the same point on the other wave. Time period would not change across the wave. if it's a pure signal. Okay? So this is known as time period, time required to complete one oscillation. It is represented as capital T. And if we have time period, we can find out frequency from here. Frequency is defined as I explained to you yesterday, number of waves per second. And frequency is given as 1 over time period. Frequency is given as 1 over second or hertz. Time period is given as seconds only. Okay? Amplitude भी कल ही explain कर दिया था. Amplitude is the maximum displacement of the wave. I guess I explained all these points here. Maximum displacement of the particle. Yes. Let me see if there is any point, any other topic left. Quality of a sound is basically, there is another term used, quality basically helps us to identify, differentiate between two sounds. So with the help of quality of a sound, we can find out the difference between the two sounds. And then there comes the last point where we discuss about the ultrasound and infrasound. Ultra and infrasound is defined as the first discuss the maximum frequency for a healthy hair. Maximum frequency range for a healthy hair is 20 hertz to 20,000 hertz. So sound above 20,000 hertz is ultrasound, and sound below 20 hertz is infrasound. Then then comes the uses of sounds. तो उसमें हमारे पास sonar आ जाता है, which is echolocation आ जाता है हमारे पास. Bats and dolphins use echolocations, and they find out the distance if there is anything in front of it. So the waves that they have sent, if the incoming wave has wavelength less than the actual one, this means there is something in front of it. If the wavelengths that they are receiving, the waves that are receiving back has a bigger wavelength, this means something is not in front of them. So echolocation help us to identify if there is anything. Supposedly, I have sent a sound signal like this. Okay? And I am receiving a sound signal which is like this. Okay? Oh. So this is input and this is output. So this shows that something is right in front of it. How we use echolocation. But if the incoming signal is like this, sorry, let me redraw it. It's only like this. Okay? Very much further apart. Bigger received wavelength indicates there something far away. This is spring, है ना? Up, if something is right in front of it, it strikes back to you immediately. So the wavelength of the incoming signal would be less than the sent one. Similarly, if the wavelength of the incoming signal is bigger than the input signal which you have sent, this means that something is further away from us. That's how we'll use. That's how dolphins and bats use echolocations. And used ये कहाँ पे होता है? Used by bats, dolphins, submarines. ठीक है? That's how they use sound signals to identify whether something is right in front of it or something is further away from it. Do we need to reduce our speed or not, or we can go faster or not? Am I clear about these points? We can also
हाँ
find
जी।
out the depth of something using this. Again, it's the same formula. V is equals to 2D over T. Ultrasounds are here. We can know that ultrasound could be used for we know ultrasound has a medical uses for to see the inside of इसको I forgot the term. इसको क्या कहते हैं? कौन सा स्कैन बोलते हैं? There's a term used
X-ray,
for this scan. नहीं
ultrasound,
एक्सरे नहीं,
X-ray,
अल्ट्रासाउंड नहीं अल्ट्रासाउंड होता है
X,
फॉर फीटस और
वो
पेशेंट हार्ट को
दूसरी चीज है।
अल्ट्रासाउंड को यूज कर सकते हैं. ठीक है, वी कैन यूज अल्ट्रासाउंड टू टेस्ट अ मटेरियल if there is any crack inside it. So ultrasound can be used to detect flaws inside a small crack. अब again वही है कि if we are sending a signal, if there is no crack, it would come back with a shorter wavelength. But if there is a crack inside a medium, it would pass through it. The signal would pass through it and would come back hitting some further on apart. Okay? So the incoming signal would be bigger than the sent one. So that's how we would know. देखो ये नहीं भेजा हुआ है यहाँ पे के सी के उसने अल्ट्रासाउंड सेंड किया, there was nothing in front of it, we got this kind of a trace. When there was something right in front of it, we got this type of a trace. This means that there is something right in front of it. So that's how we can use ultrasound to identify a crack. See this oscilloscope trace B has an extra peak. This indicates that some ultrasound is being reflected from a crack or flaw inside the metal. Okay, if we get a regular wavelengths, nothing unusual, this means there is no cracks. Sonar, I discussed with sonar is used by the submarines or the ships to again locate the depth of the sea or anything like that. Again, a pulse of ultrasound is sent down from a boat and reflects from the seabed. The time taken for the reflected pulse be received is measured. This is used when the speed of sound is the water is to calculate, and then how ultrasound could be used for to find out the crack and for the medical purposes. Am I clear about this one? We have discussed about the pitch and everything, the waveforms, the ultrasound and everything. That is the end of sound topic. Let me know if you have any questions.